you're here? Okay, great. Okay. No, I think we're just gonna. We're just gonna get started with the next panel. Um, okay, so in this discussion, we have three innovators who are in the direct air capture space. So when we think about the climate challenge, some of you may be familiar with the bathtub analogy for the atmosphere, right? Is that we have a faucet, which is our emissions, and we have the drain, which is our ability to remove carbon dioxide from the atmosphere and sequester it. We need to do both. All the scientists tell us we're not going to be able to achieve any of the global goals without both. And direct air capture has been a very exciting, promising technology that a number of customers and investors have gotten involved with. The critical challenge and what this physical technology of direct air capture gives us a window into is a broader challenge with climate tech companies, which is that when they initially start off, the cost of doing business is high because it's a new technology, it's a new infrastructure, and over time, with cumulative production, every technology goes through a learning curve. It goes through an improvement process where we get more and more efficient, we get cheaper, and we get, therefore, able to reach markets more expansively. And this has been a critical question for the direct air capture industry, where initial estimates of $1,000 to $2,000 a ton of carbon are not anything that we can imagine paying in the current carbon markets, but where the rapid technological progress is getting us closer and closer to other benchmarks, and courageous companies have gotten involved in the space. So what I want to do is just invite each of our companies here, and we have three scale-up companies who are working in the direct air capture space, and then we have Nikki Batchelor from the X Prize, who's been part of the ecosystem building around this, to reflect together on what does it take for any one of these companies to grow and get through that cost curve, and then what does it take for us to build the supportive ecosystems around this space and achieve those objectives. And I will invite Shashank to get us started.
Awesome. So, the way I think about cost down is from two perspectives. One, you have to have a low cost floor. And the second thing is you have to have a steep learning curve. We all know that solar photovoltaics really set the bar for what a cost floor looks like and what a great learning curve looks like. Yes. Cost floor is really determined by silicon, which is very cheap, and learning curve is determined by its modular nature, its mass manufacturing nature. So what can we learn from photovoltaics that we can apply in direct air capture? So for us, that means using an abundant mineral to capture CO2. To capture CO2 out of the air, it's like pulling needles out of a haystack, right? It's one molecule out of every 2,500 molecules, and it's very expensive energetically to do that, and you need a sponge to capture a lot of CO2. And that sponge has to be very cheap. If it, and the cost for what we're talking about is around $100 per ton. And if you think about, look, what does $100 per ton even mean? And in the CDR industry sort of puts this number out there, and I don't think people sort of really wrap their minds around what $100 per ton means. Can anyone guess what you can actually buy for $100 per ton today? Like, there's not that many things. Just put something out there.
Cement?
Cement, that's correct. Yeah, so cement and some sort of some parts of crude oil you can get to $100 a ton. We were just in a steel panel. Steel is $1,000 per ton. So just to put that in perspective, cement is really the only industrial good that we make at $100 a ton, and it uses limestone and very cheap fossil fuels. And that's the same principle that we try to take for direct air capture. We use limestone, which is very abundant and cheap, as a sponge for CO2. So that's really what determines the cost floor. And the second thing is cost learning curve. And for that, essentially goes back to there's two things: a scale. Economies of scale, and two is learning by doing. And for us, that means bankability, and which we'll get to in a bit. Building as many plants as fast as possible, learning from it, reducing cost. When you reduce cost, you can offer lower prices to customers, open up new markets, which increases your scale further, and then further reduces cost. So that flywheel is really why we think it gets you the steep learning curve.
Yeah, and so where is Heirloom on that flywheel right now?
So the first ever tons we sold this was about 4 years ago, was $2,000 per ton, right? We want to be very transparent with the customer about where the costs were. It's very small scale, and then now we got it down to it's much lower now. It's in the high hundreds of dollars per ton, and we're now going to mid hundreds of dollars per ton. In the last 24 months, our cost came down by about 70%. And we built 2 plants in the last 24 months, and a lot of that reduction just came from just learning by doing. The plant that we built in Tracy, California, the only commercial direct air capture facility in North America, the nameplate capacity for that is about 1,000 tons per year. In our facility in Louisiana, the same footprint is going to have about 20 times more capacity. And that's just came from understanding, we put a bunch of we put rocks, limestone on trays and stack them. So we were able to compress the distance between the trays, bring all the contactors together. And all of those things we just didn't learn for the first iteration, but we were able to after we built them.
Great. That's a great illustration of the learning curve flywheel dynamic that you're describing. Rory, what has that journey been like for you?
I think we have a similar idea of it. Yeah, and maybe pull it apart a bit in another way and talk about technology costs, which you can broadly bucket as CapEx and OpEx, and then you've also got project-specific costs.
I might need your mic a little closer.
Sure.
Yeah.
For us, I think we try to think beyond the technology into project deployment and have a thesis for how you can deploy multiple projects in a fast, iterative way that can get that cost coming down. And I think we maybe characterize it as a kind of inkblot approach. So we want to have 4 anchor locations where we put in what will be is a 10,000 ton core module, and then we'll put one in that. Put a 10,000 ton module in each of those locations. We get to know those places as well. There's a substantial learning in the project process. You get to know a community, its regulatory environment, all the rest of it. And then have options to expand as the financing, the demand, and the technology sort of next gen becomes available. So you sort of build them out in a modular way. So, to put some specifics on it, we're commissioning our 1,000 ton plant right now in Alberta. And in terms of numbers,
1,000 ton per what time period?
Per annum.
Per year.
Yeah. And that's about, not including the transportation and storage, so that's with the partner. I don't want to be specific about that. About $350 a ton for that facility. And then our target for the 10,000 ton module that we deploy next year is sub 300. Now, just sort of 2 bits I'll just add to that. One is that doesn't include financing costs, as in there's no debt financing cost assumed in that, because these are first of a kind projects, and therefore we'll pay for it from Topco equity if we need to. And then there's also subsidy in there too. But to the solar and wind analogy, of course, fiscal subsidy is a really important characteristic for helping technologies get down that cost curve quickly.
So that's sub $300 per ton in the coming year on a marginal cost basis.
That's the target
not
for next
including
year.
the debt service on the CapEx.
Correct.
Okay,
Yeah, and that
okay.
includes transportation and storage in that case.
Okay.
Yeah.
Okay. Very cool. And do you want to just say a little bit about just a couple words? We don't want to get too technical necessarily, but just a couple words on how the technology is similar or different to what Heirloom does.
Yeah, I think we're in a similar subcategory, let's say, of DAC, but we have a very different sorbent capture material and a very different contactor. So we use, if it's helpful, a fluidized bed. That will mean nothing to anyone who's not a chemical engineer, I guess. Meant nothing to me. I'm not a chemical engineer, but yeah. So it's a way in which you can blow air extremely fast. We think higher velocities than other kind of active contactors can achieve at very low pressure drops, which is crucial for the OpEx, which is
The energy consumption.
Yeah.
Great. Okay. Thank you. Malta, what does this journey look like for you?
Thanks, and thanks for taking the time. Rory has been putting out some aggressive numbers already. I was waiting when that's going to happen. But now, jokes aside, I also run a direct air capture company. We're based out of Munich. Our approach is different, as in it's a purely electric approach. And whether you're gonna, store the CO2 or use it for utilization, getting down cost is paramount. The way we look at this, or the way any direct air capture system works, is you've got a front end, as we call it. So you either use a solid sorbent, like those guys, limestone, or a liquid sorbent to contact and capture the CO2. But then the really energy-intensive step of every process is how do you liberate it again, right? And the traditional way of doing this is using thermal energy. So typically those processes tend to have high energy requirements, but also require a lot of baseload energy. But in a world where renewables are coming online cheaper and cheaper, you kind of what we focus on is can we make that process intermittent? So out of the your cost per ton is your capex and your opex. And so what is unique about us is also with our first commercial facility that we are deploying now is we basically build our own solar plant. We directly hook that up to our direct air capture facility. And we've got a chemical battery in our system. So instead of using additional battery storage to account for base load, we don't need that. And that gives us a very first principle fundamental advantage on our levelized cost of electricity that we can access, and therefore similar cost curves than you guys. And yeah, so that's really what we're about, and what we're focusing on is making DAC tuned to a renewable grid, because ultimately with data centers coming online, behind the meter solar coming online, it's a great way to couple and don't be dependent on base load.
Yep, no, that makes sense. There's a lot of other demands on the grid. Yeah, great. Nikki, I'd love to hear your perspective from XPRIZE and how you think about the evolution of this landscape.
Yeah, sure. Hi, everyone. I'm Nikki Batchelor. I run the XPRIZE Carbon Removal. XPRIZE is a foundation based in the US that runs large incentive prize competitions to help tackle new big problems, carbon removal being something that we started looking at back in 2018. At the time, we had been working in carbon management on the utilization side for several years and wanted to kind of help focus new attention and energy on this topic, which at the time there were very few carbon removal companies out there in the world. I think, we can ask everybody what their founding year was here on stage, but from our data, we had over 1,000 companies that kind of came into the competition's orbit in the last couple of years, and our data showed that over half of those companies were founded in the last few years, especially in the DAC space. So if you take a step back and just look at this industry, we all know it's very new, but it's also growing and changing and scaling rapidly. I think the progress of each of their stories is pretty impressive just if you look at the last couple of years, but I think when we look at carbon removal as a field, it's also very important to know that most of the companies, while they're still building and growing and scaling, only removed any carbon from the atmosphere in the last year or two. Like, that is how new we're talking about. There are some folks that were a little bit ahead of that curve and are moving along at a faster clip, the more known incumbents that you guys have probably heard of if you're familiar with the space. But I think that's one of the reasons that makes this such an interesting, exciting space right now. It's a great topic for Deal Day and getting everybody kind of involved. And these are 3 great examples of DAC companies. You'll see other carbon removal companies kind of represented here as well, because oftentimes DAC is the go-to in people's minds of what carbon removal is. It's not the only kind. It's important to compare that and know that there can be a diversified approach to all of these solutions. But DAC is often in the media and all of the climate news. It's really the conversation about cost. So we dove straight into that in the first 5 seconds. I didn't think we'd even go that quickly into it, but you're seeing the iteration is happening quickly, and everyone has a slightly different approach to that. I'm happy to provide more commentary as we get into other topics here, but did you want to add on?
And I should just say, the reason that we're talking about cost is because of the flywheel, right? The flywheel is ultimately, it's about scale, right? We're talking about 1,000 tons a year, 10,000 tons a year. Those numbers might sound big, but we're talking about 56 billion tons of carbon that humans are putting into the atmosphere every year. So the match of the scale means that we need an exponential of a growth curve. And a reinforcing feedback loop, a flywheel, can produce that exponential growth. But a key element of it, and what's been discussed as a barrier, is the cost. So getting that cost curve down has been kind of an emphasis within the context of trying to get to that hyperscale.
Yeah, and I think the way to think about, in a flywheel, there is a chicken and egg problem fundamentally, right? Like, which one do you push on? Where is your lever? And, over the last few years, what I've realized was the thing that actually really gets that flywheel going is bankability of the technology. When we first got started, this is not something we thought about. We were just sort of in the lab trying to figure out how to have limestone pull carbon 100 times faster than it otherwise naturally would. And we were a science company, and then we became an engineering company. We became a project execution company, building projects, putting steel on the ground. And then we realized, actually, this is incredibly capital intensive. We need hundreds of millions of dollars to build these projects. And the only way you can further scale and learn and come down the cost curve is unlock infrastructure capital. Right? There's only so much Topco capital. I tell the team, for every venture dollar we raise, we need to raise $1,000 in infrastructure dollars. And these are the same dollars that fund solar plants today, wind farms, natural gas power plants, hospitals, roadways. This is how society is built. And for a new asset class like direct air capture to unlock that, two things need to happen. One, you have to have good offtake. Good offtake by a good creditworthy entity on the other side, and an offtake template, an offtake agreement that is airtight. What that means is that if you produce the pay, they're called take-or-pay contracts. This is what they use in solar, and this essentially de-risks the market side of things for an infrastructural capital provider. On the other side of it is production. You have to show that you can be reliable. You can actually produce with this technology. You have a low operating risk, which, if you have a low operating history, that's really hard to do, right? And that's why we build these first-of-a-kind plants to get that. So for us, that's been the main focus. How do you unlock bankability? We were one of the first ones who wrote the template for these bankable agreements with Microsoft and Frontier. Meta, Stripe, Shopify, they're all part of that Frontier program. So I think that's really the big challenge for the industry right now. How do we get to financial investment decision? How do you get to bankability?
Yeah, and that speaks to what we were saying earlier about the ecosystem that surrounds these companies, right? So there's the offtake purchasers, the Frontiers, and so on. There's the banks that can provide the infrastructure financing. There's the prize that kind of help to catalyze the whole thing. What are other pieces of the supportive ecosystem that we need in order to help this get off the ground? I mean, there's the work that you guys are hard at work at, but if as entrepreneurs, if there's something you could ask of the Davos world for what would help create a supportive context for what we're doing, what would it be?
I think the bankability bit is really important. I think there's an intermediate step, which is, sort of that catalytic project equity partnership. At the minute you have people like Breakthrough Energy Catalyst and a small number of other people willing to kind of come in and co-finance first-of-a-kind projects. But I think the sector as a whole is about to some people going over that line or about to go over that line from first of a kind, second of a kind, third of a kind, and at the moment there are a relatively narrow number of people willing to kind of take that risk because they kind of are bought into the wider mission before you get to people who will evaluate it in a cold-blooded, risk and return kind of manner. So it'd be fantastic to have 15 actors like Breakthrough Energy Catalyst that are willing to come in, and help kind of get over that particular valley of death.
Yep. The Prime Coalition, which spun out of MIT, which invests in very early stage companies, identified that similarly that as sort of a second valley of death and the need for that scale-up finance. They're launching the Trellis Climate Platform, which is analogous to Breakthrough Catalyst, and so that sort of willing to take technology risk, project and asset infrastructure finance is a key piece of the puzzle. We hear that over and over again outside the DAC arena and other spaces. Well, thank you so much to our panelists. I really appreciate your sharing insights and getting your voices into the room. So folks here who want to engaged further, you can do so in the networking space next door. But let me thank this panel, and we'll welcome up our next one.